Hi guys, and welcome to the course on RESTful APIs with .NET Core. API is the engine behind today's technology-driven world. Have you ever wondered what the term API is, or heard people talking about how awesome API is? If so, you are on the correct course. My name is Progin, and I would be your instructor for this wonderful course on building RESTful APIs with .NET Core. We will be building API on a real-world project, and we will integrate that with database in this course. On top of that, I will also show you common error messages that are being encountered while building the API and how to resolve them. In this short video, we will be creating an API endpoints, we will perform CRUD operations on there, and then we will replace a temporary data store with Entity Framework Core. That way we will be able to persist our data. With that brief introduction of this course, let me get started with a quick demo from the next video. I want to show you what will be the endpoints that we will be building in this course. Basically, let me try the get endpoint. This will be used to retrieve all the villas in our project. Perfect, you can see in our database we have 5 villas. Then we can perform CRUD operations. We can create a new villa, get villa by ID, delete, put will be used to update a villa, and we have the patch. Everything will be documented in Swagger documentation here. Main focus is to guide you on all the CRUD functionalities here and what are the key points that you should remember when learning the basic fundamentals with API. So with that, let me get started from the next video. We have the big question on what is an API. The definition for an API is Application Programming Interface, but that is not explanatory. In simple words, API is responsible for transmitting the data, or rather it is a way for multiple applications to communicate with each other. In today's technology-driven world, we are connected like never before. API is the critical engine behind sharing information across multiple applications. In programming, API is responsible for getting a request from the client and then sending a response back to the client based on the request. And the request and response, there will be multiple of them, and it continues. So basically, if a client is looking for some data, it would ask API by sending a request, and then API would return back that data in form of a response. The model that we see here is the website model. What is different between that and an API? What makes an API stand out is it is not just the web browser that can call an API. Many other applications can invoke an API endpoint. So let's say you have an API that can be consumed by web application, your mobile application, your Windows application, and much more. Not only that, you can expose your API to other clients, and we have more examples of that. But before we go into those details, the example that we see here is related to programming. Let me simplify that by going to a real-world scenario. Let's say we go to a restaurant and we have menu on the table. And after a lot of thinking, we finalize on what to order. Chef is also ready to start cooking. But the missing link here is to tell chef on what we want. That is where server comes into the picture, which is basically like an API. Server would be responsible for taking order from the table and telling chef on what needs to be prepared. And that would basically resemble a request. Once the food is ready, then server will pick that food and deliver that back to the table, which will be a response. So here you can see how server is acting like an API, where it is taking the request and then it is delivering back the response from our kitchen. Now let me show you one real-world scenario which many of you would have experienced without realizing that it is driven by API. Let's imagine we are going on a vacation and we need to book tickets and hotel reservation. Like myself, I'm sure you want the best deal out there. But it will be a huge pain to go to every airline website to see what is the price of that ticket for a specific date. Rather than that, you would prefer going to a website like kayak.com, Expedia, or Priceline, where they will display the rates for multiple airlines and you can filter the best deal from their website. What happens in the backend on kayak.com is American, United, and Spirit would have exposed an API. Kayak.com will be calling those API endpoints based on date, origin, and destination, and it will return all the response from the individual website. Whatever response it returns from those websites, it will display on kayak.com. So basically, American, United, Spirit, and other airlines would have their own API, and Kayak will be calling those API endpoints to display the connected information in one place. Same thing happens when you compare hotel rates on Expedia, Priceline, or other websites, where they get information from multiple websites. So as you can see, API is the main superhero between connected services. In today's world, we take the web for granted. When we open a browser and we go to a web page, we just expect it to open up and work. That is the default behavior. But what goes under the cover is a black box. In reality, many things happen between when you search for something on the browser and what you see on the screen once you hit an enter button. Let's talk about what happens when we make such a request. We will consider an API in our scenario. For example, when we go on a laptop and search for something on google.com or any other web page, it is going to make a request to some remote server. Now this request is actually a text document. So basically it will send a text document to Google server, and this document will contain three information. First, it will have a verb which defines what is the action that server has to take. Then we have headers which have information about the request itself, and finally we have content, which is an optional field. As an example, let's say you want to create something on the server. So in that case, the HTTP verb will be post, and we will learn about these verbs in just a minute. But when we have to create, we will be using post, and that is what we have in HTTP verb. Inside header, we might have information about the content length, that the content here will be 9 byte. And finally, we are sending magic API as the content. Let's say that is a string that we want to create. So all the data will be inside the content. Now this is just an example, but this gives you a brief idea of what will be there in the text document. When the server gets this request, it can either recognize that as something it can process, or it might reject it because something might not be valid with the request. But in both the cases, it will send a response back to the client. And in that response, we will have three items again. We will have a status code, header, and content. When client makes a request, server processes that and sends back a response. Response is also a piece of data. You can think about that as another text document. The status code here basically defines the request that was made. Was it successful? Did it fail? Based on the different failed scenarios or successful scenarios, we have different status code. In our example, we did HTTP post request, so it might send a status code of 201, which stands for created. We will get to know the status code very soon, so do not worry. Right now, it says 201 created in the response status code, which means I have created the resource that you have asked me to, and I'm going to return you some data along with that. So in content type, we are saying that the data that I'm sending back is of type text, and then in the actual content, let's say the server is sending back Magic API. One important thing that you have to remember is server itself here is stateless. Stateless basically means that server will not remember things. And what I mean by that is server will be getting multiple requests. Once it processes that request and sends a response back, it forgets about that request. Because if it was remembering about all the requests, then you can just imagine on how massive the memory consumption will be, and the disk will be overloaded with the data of all the requests that it received. So always remember that server will be stateless. Based on what we have seen, we have a request that is originated from the client and we have a response. The request will have verb, header and content, and response will have status code, headers and content. In the next video, let me dive a little bit more into what exactly is in request, what is HTTP verb, headers, content, and similarly in response, what is status code, headers, and content. Let me do that in the next video. Let's understand the request object that we have. First thing in the request object is verb, and these are HTTP verbs or action. They basically define what is the action that needs to happen. If you are working with some data, you might want to create, read, update or delete that data. We have specific verb which defines what action is needed for the request. Most common of the HTTP verb is when you want to fetch some resource or a web page, which basically means that, hey, get me something from the server. So get basically means fetching some data, and that is most common. After that we have post, which is used to create or insert a new resource. Whenever you want to add a new record or anything on the server, you will be using the post request. Then we have put, which is used to update a resource that already exists on the server. Sometimes we also use patch, which basically means that please do not update the whole resource. I only want to update a part of that resource. For example, if your object has 100 properties and you only want to update one of those properties, you will use patch in that case. Put basically contains the complete resource and patch works on one part of the resource. Then we have delete, which is pretty obvious. It basically deletes the resource from the server. There are more HTTP verbs, but they are very rarely used, and typically we always play with the 5 that are most common. So that gives you a brief idea of HTTP verb and what action they are responsible for. Next part in the request object is the header. Headers are a set of name-value pair that are metadata about the request. First one you can see is the content type. That basically answers the question on what is the content type of the request. Is it a binary data? Is it a JSON file? Is it an XML file? Or is it a plain file? Then we have content length, which basically defines the size of the content. In request metadata, you might also have authorization. Sometimes request needs to be authenticated. In that case, the authorization header will be populated with a bearer token or whatever authentication you are using. We also have accept type, which defines what kind of a request is acceptable, like JSON, XML, and so on. And then there are literally hundreds of headers. You can also define your own headers if they are helpful in your situation. But headers basically have metadata of the content and request. And finally, we have content. Content is an optional field. Here we can pass the content that the server will require to complete the request. It can be a JSON object which can later be deserialized by the server to process the request. It can also be blobs that have to be created or updated. If you are trying to retrieve a resource, then you will be using HTTP GET verb, and GET will never have the body because we are requesting the API to return something, and the API does not expect any data in the request. But if you are posting or updating, then we might have to pass the object that needs to be updated or created. That way the API can extract that object from the content and process the request. This is a brief overview of the request object. That being said, let's analyze the response that we get from the API in the next video. In the last video, we saw the request object which had verb, headers, and content. Now let's examine the response object, which is basically once the request is received by the server or API, it will process that. It might be accepted, it might be rejected, failure or success, whatever it is, it will return back a response. The first thing that we have in response here is the status code. Status code is simply a number that represents on what was done on the server and its final result. But all the numbers that are returned have been arranged in some brackets, and they are very critical. Like 100 to 199 are informational. You will rarely see the 100 status code, but they do exist. Most common one that you will see is 200 to 299. Any status code in that range basically means that the request was completed successfully. 200 is most common, which says everything is okay and everything is done as requested. Then next we have 201, which means created. If you are posting something, then you can return it to someone that the resource was created on the server. That defines 201. Then we also have 204, no content. This is more common when we are updating something, because when we update a record, we just want the user or client to know that the update was successful. And we do not want to pass the updated record. In that case, we will return 204, which basically means no content. But as you can see, it is within the success bracket. That means everything was successful, but we do not have any content to return. Next bracket is 300 to 399, which are typically used when there is redirection involved. After that, we have 400 to 499, which relates to client errors. What I mean by client error means that there is an error in the request that was sent. You may not have included a query string or some part of the URI does not exist. The famous one that you would have seen on websites is 404, which represents not found. So let's say you are accessing an endpoint that does not exist. Like let's say you want to retrieve something based on an ID, but that ID does not exist. In that case, API might return back 404 that the resource that you are looking for does not exist. We have 400 status code, which stands for bad request, which means something in the request was not as expected. And then finally, we have status code within the bracket of 500 to 599, and these are for internal server error. Like the 500 here is internal server error, which means that errors have been encountered on the server while processing. So basically, the request that was sent to the server was a valid request, but when that request was being processed by a server, let's say an exception was thrown internally, and because of that, the server could not process a valid request. So that time it will send a 500, which means there was some error on the server side and nothing was wrong in the request. You can see status code plays a very important role in the response object, because based on the status code, the client will be able to know if the request was successful, if it failed, and if it failed, what was the reasons, so on. Then next we have headers in the response object as well. And they contain metadata, but this time they will have metadata about the response object. Like what is the content type, what is the length of the response content, until when it will be valid, and so on. Also similar to the request object, we have content in the response object as well, and that might contain JSON result, it might contain blobs, HTML, whatever the response, server has to send, that will be in content. So typically, if we have to compare request and response, both of them will have headers and content, but the main thing that differentiates them here is the verb and status code. Request has the verb which defines what action needs to happen, and response has the status code which defines if the request was processed successfully, if there were errors, and so on. Headers will be different for request and response, but typically headers define metadata, and content will have any content that needs to be passed with either request or response. So I hope this gives you a 10,000 feet overview about request and response and what is included in them. That being said, let's continue from the next video. First thing that we have to do is we need to create our project. I have opened Visual Studio 2022 and we will create a new project here. Next, we have to select the template that we want to use for our API project. Now, in the old days when we had templates, typically .NET used to add many of the packages that were not needed. But as we have evolved with .NET Core, they have simplified the templates as well. And now if you select the API template, it does not add any packages that are not needed. So it definitely makes sense to start with the API template that is provided by the .NET team. So on the top here, if we search for API, we have the ASP.NET Core Web API. We will be using C#, so let's select and hit the next button. The project name, let me call that Magic Villa _ Villa API. The solution name, however, we will just call that Magic Villa because in one solution we will have multiple projects. The first project that we will work on will be for Villa API. With that, we will select the location where we want the project to be saved and we will hit the next button. After that, we have few settings right here. Framework that we want to use is .NET 7, so that looks good. We will be implementing everything from scratch when it comes to authentication. So we will select none here. We will configure our project for HTTPS. We do not want Docker. And then right here, we have something new. We have use controllers and we have to uncheck that if we want to use minimal APIs. We want to learn the traditional APIs with .NET, so make sure that this is always checked. Because if you uncheck this, then you will be using minimal APIs and that is not what we want. So the default here looks good. Then we will also leave the Enable Open API support as checked. That will give us the Swagger API documentation, which we will see in the upcoming videos. And let me create the project. And perfect. With that, our project has been created. We have Solution Explorer at the right side here. Let me click that and I will pin that for now. Here we have all the files and folders that are created by default. Let's continue with all of this from the next video. Before we work on any project, it is critical to add the project to source control. That way, if something breaks or if you have to fall back to what was previously done, you always have that handy. I will be using Git for source control. In order to add the project, we will click on Add to Source Control right here at the bottom in Visual Studio, and we have the Git option right there. So let me select that and it will open the dialog right here. Now I am already logged into my GitHub account. That is why we see the account and owner right here. If you are not logged in, it will take you to the login page, so make sure to log into your GitHub account. The repository name, I will call that Magic Villa _ API. Let's scroll down here. I will keep that as a private repository for now, but once the course is ready to be launched, I will make it a public repository. That way you can examine all of the changes that I am doing video by video. This will be the URL where the API will be hosted, but you can get all of that from project resources in .NET-Mastery.com. So this looks good. Let me hit create and push right here. And perfect, you can see it is synchronized. In order to make sure everything is looking good, let me sign in to my GitHub account here. And if I navigate to my repositories here, I should have a new repository. Perfect, we have the magic villa _API. So with that, our code is added on GitHub. And let's continue from the next video. We know the basic files that are needed with our API project. But in order to set things up, they have provided some controller and a class file right here. I want to start fresh, so let me delete this weather forecast class file as well as the controller that has been added. Perfect. So now we only have the critical files in our application. We have a controllers folder, we have the app settings, and program.cs class file. So now our code is much cleaner and we only have the essential files. Let's continue from the next video. When we did the last commit, and if you refresh the page or even restart the application, you will notice here that controllers folder is missing. But if you right click here and open that in a file explorer, you will see controllers folder is right here, but the folder is empty. That is why it is not visible right here. But if you navigate, there is an icon to show all the files. When you click that, you see the controllers folder right here. In that controllers folder, we will be adding our first API controller. If you right click there, add button, we have something called as controller. We do not want an MVC controller, we want a basic API controller. You can select the API controller empty and add that, but that will give you something to get started. Controllers are nothing but basic class file with some special notation. In order to learn that, what we can do is inside the controllers folder, rather than adding a controller, let me add a class file here. And what makes a class controller is the name as well. We want to call our controller Villa API. That is the name that we want. In order to make that a controller, it must stand with the word controller. So because of that, our controller name will be Villa API, but controller is the keyword that needs to be present in the class name. With that, let's add that class file. Once that is added, you can see controllers folder is visible, and if you uncheck the show all files here, bin and obj folders will go away, but controllers stays here. So now we just have a basic class file with the name of Villa API controller. Now in order to make this a controller class, it has to derive from the class controller base. We will press Ctrl dot here, and we have the using statement with controller base that works. The controller base contains the common methods for returning all the data and users that is related to the controllers in .NET application. If you were using an MVC application rather than controller base, that will be derived from the controller base class. But when we use the controller base class, it also has support for views that are used in an MVC application. But our application right now is an API application, so adding support for the MVC views will be an overhead that we do not want. So we will not use any of the classes or overhead that are not needed. We will stick with the minimal one, and then if we have to add something else here, we can of course change that. Finally, the last thing that is needed here is the attribute, which is API controller. That notifies the application that this will be an API controller. And with that, we have created our first controller. Right now, our controller is basic. There is nothing fancy in there. It does not have any endpoints as well. But we have created the base class for our controller. With that in place, let's continue from the next video. An API typically returns some data. We do not have any model or any class that needs to be returned. In order to do that, inside the main folder, we will create our first model. We will add a new folder. I will call that as models. And inside there, we will add our first model, which will be Villa model. So let's call that Villa and let's add that. Inside here, we will create two properties. So let's say the first one will be ID of the villa and next one will be name of the villa. That will be a string. Perfect. So we have our model. Let's close that and let's work on the API controller. We want to create an endpoint right here. So that method will be public and it will return list of villa. Return type here will be an IEnumerable of villa. We have to add the using statement for our model and we will name the method getVillas. Let's add that. In the method here, we want to return new list of villa and I created two villas right here. ID will be 1 and 2. Name I'm calling pool villa and beach villa. The endpoint here looks good and it is returning two villas right now. Now you need to think about we have an endpoint here. How do we invoke this endpoint? Without doing anything here, if you try to run the application, you will run into an error message. Let me show that. And great. Inside our program.cs, we have an error where we can see the getVillas right here does not have an attribute route. Action methods on controllers annotated with API controller attribute must be attribute routed. So basically what it says is we have an API controller here, but we have not defined the route to this controller. Adding that route is super simple. We have an attribute called as route here, and within the parameters here, we need to give our API some route. Typically we use API and then / we want to use the controller name, which is Villa API. So we can copy this and paste it right here, and that will be the route of this controller. With that, let's run the application and see what happens. And perfect. This time the page loads, but we have an error here, failed to load API definition. What we see here is the Swagger documentation. That error message basically tells us that the endpoint that we added here, something is invalid right here. And what happens is when you add an endpoint to API controller, we need to define what is the HTTP verb of that endpoint. Here we are retrieving all of the villas, and that will make this an HTTP GET endpoint. So we have to define that on top of the endpoint, not at the controller level, but at the endpoint or the action method level. So this will be HTTP GET, and we have to write that in attribute like this. That will notify the Swagger documentation that this endpoint is a GET endpoint. With that change, let me run the application once again, and this time the documentation works as expected, and Swagger is able to identify the endpoint as a GET endpoint. Because of Swagger here, we will not need Postman. We can directly test this right here. We click on GET. We have the try it out here. It does not expect any parameters. We will hit the execute button, and in the response here, you can see we get both of the villa that we wanted. So our endpoint is working as expected. Right here, we have the request URL. So if you want, you can copy that and paste it right here, and it returns the same data. So this is basically hitting the endpoint directly. Swagger UI is a fancy documentation where it will display all the endpoints, and you can test them, you can clear them and execute once again. We will explore more options here in the upcoming video. But right now what we have accomplished is we are able to navigate to our first endpoint in the controller. And the endpoint that we created is an HTTP GET endpoint. So with that in place, let's continue from the next video. Now that we have added the routing here, you can see we are using the controller name. We also have something where we can automatically use the controller name here in the square bracket. If we write controller, that will automatically apply Ssl API to the route right here. Let me run this and show that. Perfect. You can see the route here is API, Ssl API. If we try that, that should work. The request URL, that stays the same. But I am not a fan of using the controller like this, because what happens is down the road, if for some reason you have to change the controller name or the file name here, because what happens if in future you have to change the controller name? The route will automatically change for all of the connected clients. So if your endpoint is used by many consumers, you have to notify all of them that the route has changed. And that is a huge pain. Because of that, I like to hardcode the route here, and that will be Ssl API. So even if down the road if you change the controller name, your route does not change, it will stay the same. But I wanted to show you that if you want to use the controller name, or if in any of the existing application, you see controller right here, do not panic. That means that we are using the name of the controller automatically inside the route. I will leave that in comment here. That way you can always remember that. With that route overview, let's continue from the next video. Typically in a real world scenario when you will work in API, in our controller here, we are directly using the Ssl model. But that is not a desired situation in production application. We have something called as DTOs. DTOs provide a wrapper between the entity or the database model and what is being exposed from the API. Let's implement that. Inside the models here, let me add a new folder for DTO, and in there we will add a new class file. We will name that Ssl DTO. Inside Ssl DTO, we will add the same properties like ID and name that we have for Ssl. But if we go back to our Ssl here, let's say that in the database, we have one more property, which will be date time, and that will be created date. That will define when this record was created. But when we expose that to the end user of our controller, we do not want to send that date. So here, rather than Ssl, the return will be Ssl DTO. We will have to add the updated using statement, and we will create a new list of Ssl DTO. Simple as that. So right now, we are not using the Ssl model that we have. We will use that down the road, but we are working on the Ssl DTO that we added. If you run the application, everything will still be the same. Let's test that. And great, that is returned successfully. If you see the schemas here, now we have the Ssl DTO, and that looks good. With that in place, let's continue from the next video. Inside API, we typically perform CRUD operation. So we will be adding new Ssls here. We can update any of the Ssl DTO. For that, there is typically a database where we will store all of our Ssl. Right now in our application, we do not have any Ssls. We do not want to complicate things by adding database right now, but we can create an on-the-fly data store. Inside the main solution here, let me add a new folder for data, and inside there, we will add a class which will be Ssl store. We will make this a static class here, and inside there we will have our Ssl list. So let me cut this. Let's go back here, and it will be public static list of villa DTO here at the using statement. I will call that as villa list here, and we will paste what we copied. So perfect, we have the villa list here. Inside the API controller, we will add the villa store. At the using statement dot, we can access the villa list and return back. Let's run the application and make sure everything still works the same. We try it out, and perfect. Now we have added the villa store where we have a list of all the villas that we will use in the application. Now in our controller, we have the first endpoint, which is HTTP GET, and that is getting all of the villas. But what if we want to get only one villa based on the ID? So basically, let me copy this and create one more endpoint right here. Rather than get villas, we will call it as get villa, and here we need an ID in the parameter. Based on that ID, we will filter our villa list here. We can use first or default, and we want to get the first one. What we are using here is a link operation where on all the list, we want the first or default. That means based on the condition that we add in the bracket here, where we are saying the ID should be equal to ID that we pass in parameter, it will retrieve one ordinal record. So the return type here will be just one villa DTO. It displays a warning here that this can be null, because if the ID that is provided here is not a valid ID, then it will return null, and that is completely okay. So now we have two endpoints right here. We have to define what will be the HTTP type here. This will also be an HTTP GET, but it will only return one record. This will return multiple records. With that in place, if we run the application here, we will see an error message. Great, you see the default error with the Swagger documentation. That basically tells that whatever code that we added in our API, something is not valid here. In order to test that, let me copy the local host here, and let me go and try to navigate to the endpoint that was working before, which is API/villa API. And we see an error message that makes more sense here. It says ambiguous match exception. The request matched multiple endpoints. So basically, when we have the API endpoint, it is getting confused on whether it should invoke the get villas or get villa. Now, why is it getting confused? We have defined in get villa that an ID is needed. So if the ID is not present, it should by default take the get villas that will return multiple villa. But that is not the case. There is the confusion here. And the reason behind that is the definition here. It notices there are two HTTP GET calls. In order to define that this HTTP GET call expects an ID parameter, we have to explicitly write ID like this. That will define that the get villa expects an ID parameter and the get villas does not expect any parameter. So once you add that, if you restart the application, everything works right now. If you try the one with ID and you hit try it out, we have to pass the ID here. We pass 1 here and it will retrieve the villa with ID of 1. So great. Both of our get endpoints are functional and that is looking great. Here you can also be explicit and define that this ID is actually an integer. Let's run this and it will work the same way because we provided an integer. Let's execute this and perfect. That is working as expected. So with that we have seen how to retrieve the individual villa. Let's continue from the next video. We need to define what will be the return type. When we work with API, we have different status code that we need to define with all of the endpoints here. One way of doing that is rather than defining what will be the return type like IEnumerable of villa.dto, we can use action result here. Action result is the implementation of interface iActionResult, and with that we can use any return type that we want. But right here you can see it returns an IEnumerable of villa.dto, but if everything is good in this case, we want to return an OK object that produces an empty status code. You can see 200 OK. That is the result that we want. So we will say OK here, and we will pass villa list as parameter right here. We have the same 200 OK when we return individual villa as well. So let me copy this OK here, include that in the parameter, and the return type will be action result of type villa.dto. With that in place, let's run the application. Let's examine the get here, and let's try that out. We execute that, and everything looks the same right now. Nothing is different right now because we are returning a 200 OK, and that is the response that was there before as well. But now I want to add something special. When we are retrieving the get villa, we want to add some validation. Like here, we can check if ID is 0. That means that it is a bad request. So we can return back. We have a status code for bad request, but we also have that included in the controller base class. So we can just say it is a bad request. When we are retrieving the individual villa based on the ID here, we can store that in a variable. We'll say villa is equal to, let's retrieve that. And after we retrieve, we can do one more check here. If villa is null, then we want to return not found. So we will say return here, and we have something called as not found, which is basically a 404 that you have seen on website. Many times you see 404 exception, not found. We will return not found if it does not find any villa based on the ID here. And finally, if everything looks good, we will return an OK, and we will pass the villa that was retrieved. Perfect. With that, let's run the project. And this time, we will try it out. First, let me enter 0 here. And you see, we get the 400, which is bad request. If you enter an ID that does not exist, like 4, and execute, we will see a 404 not found. And if you enter something that exists here, it will of course return a 200, and we have the villa right here. So perfect. With that, we have added multiple status code inside our controller endpoints. In our get villa, we are returning bad request and not found. Let me run the application again and show you something different here. When we do that and try it out, enter something that does not exist, it does return back a 404 here, but you see something called as undocumented. It is the same case if you return 0 here. We have undocumented. It does return the status code, but it is not documented in the API. It makes sense to document what are the possible status code that this endpoint will return. And to document that, we have the attribute here, which is the produces response type. Here we can define what are the multiple response type that can be produced. We have 200, that looks good for OK, 404 is for not found, and we have 400 for bad request. With that, let me save that and run the project. Now, if you do get here, and if you try something invalid, undocumented will not be present anymore. On top of that, let me clear this, and if you scroll down in the responses, now you will see there are multiple responses that are possible. A 200 OK, 400 bad request, and 404 not found, all of them are the possible response type. If you scroll down for the 200 OK, you can see the expected response model is ID and name, and that is our villa model. Now how it is getting that? It is getting that because right here in the iAction result, we have defined the return type is a villa DTO. So that being said, what happens if we remove that? Let me run that. If we open here, this time, you can see this time it does not know what model will be returned if everything is successful. If you want to define it in another way, right here where we have produces response type of 200, you can define what will be the type here. That will be a type of villa DTO. With that, let's run the application. If we try the get now, you will see it knows that a villa model will be returned. So that is great. If we have villa DTO here, then the type here is not needed. Another thing, we have hard-coded the status like 200, 404, and 400. If we want to make it a little cleaner, let me copy and paste that one more time. I will uncomment this one, and we do not need the type anymore. Let's remove that. Rather than 200, we have that inside status codes, and there we have all of the status code. We have 200 OK. If you press F12 here, it is nothing but a constant with the value of 200. But if you had to read this line versus the 404, which one makes more sense? Of course it is this one, because you can see it is status 200 and OK. Similarly, let's do the status codes here. And next one is status 400. It defines that is a bad request. We need the 404 again, so status codes dot status 404, that is not found. This is more explanatory rather than writing the integer constant. And then for the first one that we have here, it will always return a 200 OK. So with that, we have added the response type for both of our endpoints. Let me run and make sure everything is still functional. Let's get all the villa here. That works. Let's try to get an individual villa here. And perfect. That also works. So with that, let me remove the other two here. I will just leave one of them here for reference. And let's continue from the next video. In our API, we have used HTTP GET into endpoints. We are getting multiple villas here, and we are getting one villa. Next, we want to work on creating a villa. That way we can add a new villa in our data store that we created. When we are working with creating a resource, at that point, the first thing we should notice is the endpoint, and that will be HTTP post. That is the HTTP verb used when creating a resource. We need to create the endpoint, which will be public action result, and this will be of the type villa DTO. Whichever villa we create, we will return that back. And then let's call the method or action name as create villa. And in the parameters, we need the villa object that needs to be created. Now, when you are working with HTTP post, typically the object that you receive here is from body. So we will add that attribute right here. Then we need to work on creating the villa here, but we can add validations. So for validation, we can check if villa DTO is null. Then we can return a bad request, and we can return back the villa model. When we are creating a villa, the ID of the villa should be 0. So if in case that ID is greater than 0, that means that this is not a create request. So we will return back the 500 status, which is internal server error. You can also return bad request But if you want to return something that is not in the default action result, you can just say return back the status code and then the code itself. So the code is status 500 internal server error. That is how you can return custom error message if they are not within the default action result, like bad request or not found that we have seen so far, along with OK. Then ID is typically an identity field, but for now we will assume that user enters a distinct ID every time, and we will not consider the other scenario only for now. Then the villa ID that we have so far in our villa store, we just have 1 and 2. So we can retrieve the maximum ID here and increment that by 1 and assign that to villa dto.id is equal to. We will go to our villa store.villa list. In there, we can order by descending. We want to get the maximum ID, so we'll say u goes to u.id. Because of order by descending, we will have the biggest one at the top, and we will retrieve the first one. From there, we don't want the complete villa object, we only want the ID, and we will increment that by 1, assign that to the villa dto.id. So perfect, this looks good for fetching the next ID. And finally, this villa object we can add to our store. So we'll say villa store.villa list.add, and we will add our villa DTO. Finally, once everything is done here, we will return OK, and we will pass the DTO object that was created. Now we need to add the response type here. We have bad request, we have status 200 OK, and we have status 500. Now the changes for HTTP post looks good. Let's run the project. So perfect, we have the HTTP post here. Let's click there, and then if you select write out here, inside the request body, you can see by default it is displaying the ID and name here. We also have type here, like application JSON, text JSON. The most common one is application JSON. When we are creating, the ID will be 0, but the name, let's say Bliss Villa, and try to execute this. We scroll down here, the response here is 200 OK, and perfect, you can see the new ID that is assigned is 3, and we have the name. That looks great. Then let's try to get all the villas here, and perfect. Now we have 1, 2, and 3. Now if you restart the application, this will go away because we don't have actual database to persist this. So it is only meant for temporary testing while we learn the basics of API. So perfect, this looks good for HTTP post. Let's continue and modify our HTTP post in the next video. So perfect, our HTTP post is functional now. But when we create a villa, it returns a 200 OK. Now that is completely OK and acceptable. No issues at all. But sometimes in an API, you want that when a resource is created, you give them the URL where the actual resource is created. So basically you want a link, that way they can call the getVilla with the ID of the new resource that was created. To accomplish that, rather than returning OK here, we have something called as created@route, and then we give them the route to the new villa that was created. So in the parameters here, the first parameter is the route itself. So in order to find the resource where it was created, we need to call this getVilla. But this getVilla endpoint does not have an explicit name right now in the controller. If you want to give your HTTP GET or any method explicit name here, along with the ID here, we can add comma, and we have something called as name. Let me give this an explicit name of getVilla. Once we add this name, we can use that the created@route, you have to invoke the getVilla here. And when you invoke the getVilla, it expects an ID which is integer. So right here, we will say comma, and we will pass that in a new object. That ID is inside villa.dto.id. And finally, to the getVilla, we will also pass the complete object that was created. So that is how you can invoke the created at route. With this change, let's run the application and see this in action. Let's do a post again, try that out. We will call that tester 0. Let's create. And if you scroll down, the response now is not 200, it is 201. And that is because created at route, the return code is 201. But in the response, you see it gives the API location on where it is created. So basically this location, if you copy that and paste that in a new window here, that gives the new record that was created. So perfect, that is working as expected. We need to fix the undocumented. So that is status 201 created. Let me stop the application, but perfect. With that, our HTTP post looks good. Let's continue from the next video. Then what if we want some validations while we are creating a villa here? We have our villa DTO. What if we want validation that name should be a required field and it should have a max length of, let's say, 50 characters? There are built-in data annotations that are available with .NET Core. And data annotations, you can apply them on the model class. So right here for Villa DTO, if you want to apply a required data annotation, here you will just add an attribute, and that is required. We will press Ctrl dot. We have to add the using statement for system.componentModel.data annotation. That will make sure that if you try to create name which is empty, it will give you an error message. Similarly, we have something called as max length, and let's say our max length here is 30 characters. So if it is more than that, this will also show an error message. With that in place, let's run the application and try that. Let's do a post here, try this out. Let's remove the name and try to execute. We scroll down and we see the error here, name is required. Now, how did our API know that they have to follow or they have to use this data annotation? We did not write any code in the Villa API controller. The reason behind that, if you scroll up here, we are using this API controller, and that gives us some additional help on the controller because it identifies that as an API controller and it automatically includes the basic features. If you comment this out and run the application, you will notice that the validation will be no longer active. So we try that here, and perfect. And this time you see a 201 created, and it actually created an empty name Villa. Let's do a get here, and you will see that right here. There you go. Our API is still functional without that API controller attribute, but it will miss some of the basic features that are included. What if you do not want to include that and you still want the validations that we added using data annotation? In that case, you have to explicitly check the model state. Right here, we can check if, and model state is something that is built in with the .NET Core. So model state dot, we directly have to check if it's valid, if it is valid or not. Model state basically means the model that we have, which is Villa DTO in this case. So if the model state is not valid, in that case, we want to return back. So we want to return a bad request, and in the parameter here, we will pass model state. That will display the error message. So with that, let me run the project. Let me also add a debugging point because I want to show you what model state is. So right here, try this out, remove this, execute. It should hit our breakpoint. And right here, if we examine the model state.isValid is false. But if you go to model state, it will display you which property is not valid. So in the values here, result view, you can see there is name and that name is not valid. If you expand that more, you will see the exact error message, name field is required. So if we continue here, it will return a bad request and we see the error message, name is required. So that is something that you can implement if you have some custom validations and you want to add that to the model state and return back. We will comment this out and we will use API controller. That way we get the built-in support for data annotations. So with that in place, let's continue from the next video. Now in our Villa API controller, where we have the model state, if you uncomment this for a second, add a debugging point, and we have the API controller enabled as well. Let's run the project. This time, if we try to post with an empty name here, you will notice we get a response here and it displays the error, but it does not hit our breakpoint. That means that model state validation is done before it hits this breakpoint, and only after model state is valid, then the breakpoint enters the action method if API controller is enabled. That is something that you should keep in mind. On top of that, let me copy this, let me comment this out, and then let's say we want a custom validation that villa name should be unique. So when we are creating a villa, we need to make sure that that villa name does not exist in our store. So we will say if villa store.villa list.first.default, we want to check the name and we will convert that to a lowercase. So .toLower is equal to villa dto.name.toLower. If first.default is not null, that means that the villa name is not unique. Perfect, that looks good. In this case, we want to add a custom error message in our model state. Adding that is super easy. We will say model state.add model errors, and here the first parameter is empty. The first parameter denotes the key name. What happens is when we are binding the model state in villa DTO, if the name is not valid, name will be the key name and value will be the validation. But this is a custom validation, so you can write a name like custom error if you want, but the key should be unique. Even if you keep it empty, that's completely okay. So we add that to model state and then we have to return back. So we can return bad request here and we will pass model state in there. Let me test that. We will post again. Name I will use as test here. Execute. That creates it. Let me try to execute this once again. This time we get the key name, which is custom error, and then the error message villa already exists. And the return type here is 400, which is bad request. So perfect. With that, we have seen how to add custom validation and add them to model state. So now we have get and we have post that is used to create a villa. There is also something to update a villa, which is HTTP put or patch. But before we go into that detail, let's add the endpoint to actually delete a villa. So the HTTP verb for that is HTTP delete, and when we are deleting a villa, we will delete it based on the ID. So if you remember again, when we have to delete based on the ID, we need to write that in parameter that the method expects an ID. Let me copy this, paste it here. We can give this a name. Let's call that delete villa. That's not needed, but if you want, you can give that a name. After that, we need to create the delete villa, and the return type here I have used iActionResult. If you use ActionResult here, you can define what is the return type. With iActionResult, you do not define what is the return type. And when we delete, we of course do not want to return any data. We will return something called as no content. That is why you can use iActionResult. We have to delete based on the ID here. We can use the same validation that we had in create villa. Let me copy this. Actually, this is villa DTO is equal to null. What we want to check here is if ID is equal to 0, then we will return bad request. If the ID is not equal to 0, then from the villa store, we will use first.default and retrieve the villa that we have to delete. We will check then if villa is null, we will return a not found, but if we do find that villa, then we will use our villa store. On there, we have the villa list. We will invoke remove, and we will pass the villa that we want to remove. Now, when we were creating, we can return created at route or OK. But when we delete, typically we use return no content. Now, of course, you can use return OK. There is nothing that is set in stone. This is your API and you can design it the way you want. But when we delete, we do not return anything. That's why we will return no content. And the status for no content is 204. So right here, we will add the response type, which is 204 no content, 404 not found, and we also have bad request. Those are the 3 response types that are possible with delete villa. Perfect. Let's run this and test that. Great. Delete is here. Let me first create something. Test. We will have third one. If we do a get here, we see 1, 2, 3. That's perfect. Let's scroll down. Try the delete. We need the ID. Let me delete the second one here. And the response is 204, no content. Looks good. If we try the get again, now we only have 1 and 3. So perfect. Delete is also working as expected. With that in place, let's continue from the next video. We have get, we have post, and we have delete. Last thing that remains here is what if we want to update any of the record? There are 2 ways to update. First one will be using HTTP put, and that will update the complete villa record. And that is the most common way that is used to update a record. But we also have something called as HTTP patch, where we only update one of the field in the complete object. So before we take a look at HTTP patch, let's see HTTP put in action. We will add that verb here, and then we need to create the method. So let me call that public iActionResult update villa. We are not returning anything here when we update. If the update is successful, we just return no content. Then what will be the parameters right here? When we are updating, we want to retrieve the ID of the record that needs to be updated. So here we will get that integer ID. And then from body, we want to retrieve the villa DTO. So we'll retrieve the complete object that needs to be updated here. Now you might say, if we have ID in villa DTO, why do we explicitly want to get an ID? I like to double check when we are updating. So here we will add if. We will make sure villa DTO is not null. If it is null, we return bad request. And I will also double check that the ID that we receive here is the same ID that is inside villa DTO.id. If that is not, then this is a bad request. Now since we have ID here, we can copy this. Well, not all of that, just the parameters here. And we have to tell that this endpoint expects an ID. And we can call this update villa. When we are updating here, we will retrieve the villa from our villa list based on the ID that we have right here. And then this particular villa needs to be updated. Now, right now, if we go to our villa DTO, we just have name here. Let me add two more properties, occupancy and square feet. We will have to update our villa store, populate them here. So we will add square feet, occupancy. Perfect. Looks good. Let's save that. Then in order to update, we will update villa.name based on the DTO name. Same applies for square feet and occupancy. Once we update here, we will return back no content. So that looks good. With that in place, let's run the project. And perfect, we have code right here. In order to try that, we know the ID 2. If we go back to the code, inside the data villa store 2, it is beach view. Let's change that. So right here, we need the ID as well. Let me actually change the ID to be 1 for now. We'll change this to be test. 10,000 square feet is 10. Let's execute. We should see error message. Perfect. We have 400 and that is bad request. Because the ID are different, if we keep both of the ID same, this time it will update and we will have no content, which is 204. Let's go to get here and see what we have in the store. Perfect. This is updated successfully. Let me just go back to the code. We will have to add the response type. So let's copy that, paste it here. We have bad request. That is good. We have no content. We do not need the 404 not found here. We have no content. Perfect. That looks good. Now our update is working successfully. But think about a scenario where you have hundreds of properties of a model and you just want to update name and nothing else. If you update the complete model, it will be a more resource-intensive task. In order to update only one property, we have something called as HTTP patch. Let's see that in the next video. In this video, let's take a look at HTTP patch where we can update only one property. If you want to read more about that, we have patchjson.com, we have the jsonpatch.com, and there you can view everything related to the patch and how it works. If you scroll down, there are multiple operations. Like if you want to add only one thing, you can use add. If you want to remove, you can use that. We will see if we have to replace name with something else, how to do that. You can of course test everything else here, but let me walk you through one example. In order to add patch support, we have to add some of the Nuget packages in our application. So let me keep this open in a new tab and close the application. We have to manage the Nuget packages. Let me close everything here. We can right click here and select Manage Nuget Packages. There are two Nuget packages that needs to be installed here. The first one here is Microsoft.ASP.NET Core.JSON We have the .NET 7 version. Let's install that. Make sure to install the same version that you have and not different version. I am using Preview 5 for this course, so even if a later preview version is available, I will not use that and I will stick with the same version. The next package here is Microsoft.ASP.NET Core.MVC.NewtonSoft.JSON. Same version here. Let's install. These are the two packages. NewtonSoft.JSON, once you add the package, you will have to include that in program.cs. Where we are adding the controllers here, we will have to add NewtonSoft.JSON, and that way support is added to the service. Simple as that. Let me save that, and with the Nuget packages installed, let's continue with HTTP patch from the next video. Now that we have installed the Nuget packages, let's open the Villa API controller and we will add an action method for HTTP patch. So after we have the update Villa, that HTTP patch will also include the ID and we'll give that a name of update partial Villa. The response type will be 204 and 400 bad request. Those will be the two that it will return. Then for the action, we have the public iAction result update partial Villa. Here we will receive the ID, and next when we are working with patch, we will receive something called as a patch document. So this will be of the type JSON patch document. We will press Ctrl- and add the using statement for Microsoft.ASP.NET Core.JSON Now, of course, this document will be nothing but a Villa DTO. So here we define the class that this will be of type Villa DTO, and let's call that patch DTO. Something different. We will add validation if patch DTO is null or if the ID is 0. This is a bad request. Now, if the ID is not 0, then we can try to retrieve Villa from our Villa list here. Once we retrieve that, you can add another validation. If Villa is null, we can return bad request or we can return not found. Now, if we have found the Villa, our JSON patch document will have what needs to be updated. So from that, we just need to apply that on this Villa object. So we'll say patch DTO, and since this is a JSON patch document, there is something called as apply to. We want to apply that on our Villa object, and if there are any errors, we want them to be stored in the model state. That is the syntax that we have with the patch document. If model state is not valid, we can of course return back a bad request, but if everything is valid, we will return no content. Now if we go back to JSON patch here, you can see where we have to replace something. We need operation, the path, and the value. So let me run this and see what happens in the Swagger UI. Perfect, we have a patch here. Let's try that. We have some more operations here which we do not need, like operation type or from. We just need path, OP, and value, and that looks good. So operation will be replaced here. Then path basically means what is the property name that needs to be updated. So we want to update name of the Villa and we need to pass the ID. We just have ID 1 and 2 when the application starts, so we will update the second one. And what is the new value of the Villa name that we want? Let's make it new Villa 2. Let's hit execute here. And if we see the response here, it is 204, no content. We can get that and see if it was actually updated. And perfect. You can see the Villa name of ID2 has been updated to new Villa 2. So again, if you want to go into more details about how the patch operation works, you can go to jsonpatch.com, but we have seen replace in action. You can change the operators here to test the other scenarios, but with that, our patch looks good. We did all the testing of our API using the Swagger UI right here. But same thing you can also do using Postman. So let me open Postman on my local machine. You can download the application. It is completely free, and we will just skip and go to the application. You can of course sign in if you want, but we can start without that. Get started here. We will click new here and an HTTP request. We can select the type of request that we want. Let's work on the GET request, and we know the URL. Let's copy the path, which is localhost here. And then we have API, followed by Villa API, and let's send this. Once you try to send that, we see an error here, unable to verify the certificate. We have to disable the SSL verification. Because right now, even though we are using HTTPS here, that is meant for the local development and not an actual certificate. So we will disable that on Postman, and once you disable, perfect, we see the response. So get all is working. Now if we want to get based on the ID, we will pass the ID here, hit the send button, and that is also working. After that, let's try to create one. So we will have post here. Let me copy the one that we have here. And for post, we don't need any ID here. When we are sending that, we need to pass the body of the new villa that we want. So that we will add inside body here. So inside body, we will select raw here. And let me paste that. When we are creating, we don't need an ID here. Let's change the name, occupancy, and square feet. Let's hit the send button. As soon as we do that, we will run into an error message. Perfect. We have 415 unsupported media type. That is because the raw data that we have, that is in a JSON format. Once you change and send that, perfect. New villa has been created. Now if we try the get again and send this, we see all the 3 villas right here. Great. So post is also working. Next, let me try put here where we have to update. In order to update, we will need the ID as well. So let me copy one of the ID here. This one is ID 3. Let's change the name to 3333. When you add this and try to send, it will give you an error. We did not pass the ID here. So we need to pass the ID and send it. Perfect, we get 204 no content. That means the data was updated. Let's do the get request again. And great, the data is updated here. After that, we have the batch request and we need the parameters or model for that. We can just copy this, go back here and paste that. We want to replace the name. New villa, new finale will be the name. What will be the ID? Let me replace the third one here and send it. This time we see the error, JSON batch document was malformed and could not be parsed. That is because the JSON document we have to pass as an array. So let's add that and try it one more time. Perfect, we get 204 no content here. Let's try the get with the ID, that's okay. And great, the name is updated. So we have seen all of them. The last one that remains is to delete. Let's delete the third one, 204 no content. Let's do get and try to get all of them. We only have 1 and 2, so the third one was deleted. Perfect. So with that, we have tested all of the endpoints using Postman. Because many times it will be possible that if you are working with some API, Swagger documentation is not available. In that case, you will have to fall back to testing everything using Postman. You will have to pass headers or body based on the content and so on. So I hope this gives you a brief idea on how to use and navigate in Postman. With that, let's continue from the next video. Now inside the get call here, you can see by default there are few headers. If you expand them, we have some of the default header settings provided by Postman, like the accept type. And you can see here the accept is set to accept any value. So we have not set any of the value, but when we hit the send button, we get back JSON response, which basically means that our API has the default type of JSON. So if we explicitly set that to application JSON, let's see what happens. To set that, let me hide this, and I will set the accept here to application /JSON. Perfect, our API works with that. But what if we set the value to be XML? If we send that, that also works. So that basically means that the data that we retrieve here is not XML, but whatever accept type we are setting, API always returns back JSON. What if we want to be explicit? If the application type is not JSON, then we want to display an error message. Doing that is super simple. Let's go back and let me open the code here. We will go to program.cs. Where we are adding the controllers here, we can define the option. So I'll say option goes to, and right here we will say option dot. We have returned HTTP not acceptable. So if a format is not acceptable, we will return the appropriate error message. Let me save that and let me restart the application. Once that is up and running, we can switch back to Postman and let's try the XML. We get 406 not acceptable. So that is great. Now what if we want API to support XML formatting? Adding that is super simple as well. On the add controllers, we will have to write add XML data contract serializer formatters. And that will automatically add the built-in support to add XML in our API. So once it's running, if we go back and try that, perfect. You can see the output is now in XML format. So these are some of the basic settings that you should be aware of when you are working with APIs. In any application, logging plays a critical role. And logging by default is built in inside the console window with the .NET framework. Logger is already registered inside the Create Builder when the application is being built here. But right now in our Villa API controller, we are not using any loggers. In order to use that, since logging is already registered in the application, we just need to retrieve that in Dependency Injection wherever we want to consume logging. In order to see that logging is already built in, if you go to Solution Explorer, inside the app-settings.json, you can see we have some section for logging. The default log level is information, and with ASP.NET Core, we have warnings that we are logging here. But where are these logs? If we run the application in the console window, let me pull that open. In the console window here, you can see there is just some information right here. What if we want to log some more details inside the console window? How can we accomplish that? Let's close this. And that console window, if you do not see that, that means you are running on IIS Express. So switch that to the one that is project name here and run that, and the console window should come up. This is the one that uses Kestrel while running the application. Now the main question is, how do we log inside our Villa API controller? In order to log here, we need to use Dependency Injection. Because like I said before, Logger is already registered in our application. So whenever we need an implementation, we just need to ask for an implementation of Logger. And that will be done inside constructor. We will press CTOR and press tab twice for snippet. And here we just need to write what we expect. We expect an iLogger here, and right here we have to provide the class. So that class name is Villa API Controller. We'll call this _logger. We also have to create a private variable here. Once you are on the logger, if you press Ctrl dot here, we have an option of create and assign field of logger. That creates a private read-only field and assigns that with _logger. So what happens here is, because of dependency injection, .NET Core will provide the implementation of logger inside the _logger here. We don't have to instantiate the class or worry about disposing everything is taken care by dependency injection. We directly get an implementation here. We are using that in logger, and that is what we will be using in the rest of the controller. Now the private variable is typically I like underscore, so I will just swap that. Then let me scroll down where we have the get villas. Let's log something. So we'll say underscore logger dot. We can log information here, and we will say getting all villas. We scroll down where we have the get individual villa. If ID is 0, let's log an error here. So we have log error here. We will log the get villa error with ID of 0. Perfect. So with that in place, let's run the application and try this out. We have our console window here. Let's try to get all the villas here. Try this out. Execute. Perfect. If we go to our logs here, you can see info. We are getting all the villas. That looks good. Let's try to get the individual one and try that with an ID of 0. We do not see an error here because we see. If we scroll down, we see 406 undocumented. Let me see the type that we have here. And right here, if we scroll down, where we have the 200 success, the media type is text plain. We made the change that we should have application JSON. So with that, if we try to execute this again, perfect, we get the bad request. Let's examine the logs here, and we get the error message as expected. With that, we have seen the default logging in the console window, but let me make one change in the program.cs where we added the option here. Let me comment that out for now. That way, when we are using Swagger, if we use the plain text, this will still work. Let me test that once again. So perfect, let's try the get now with the ID of 0 here, text plain, execute this, and perfect, 400 bad request. And if we examine the logs here, error message also looks good. With that, we have seen how to use dependency injection to get the iLogger implementation that is already registered in the application. Right now, we are logging everything to the console window, but typically in a production application, you would want to log everything to some file. That way you can retrieve the logs and check something out if needed. For that, what we will do is in solution, we will be using third party. There are multiple third parties like Log4net, Sirilog, and much more. We will be using Sirilog here. If you search for Sirilog here, we have Sirilog.ASP.NET Core. That is the package that we want to install here. And based on where we have to log, we need another package. We want to log in a file here, so we will install Sirilog.syncs.file. If you wanted the same console logging that you had, you would use Sirilog.syncs.console. If you want both of them, you can of course do that as well. We will go with Sirilog.syncs.file, and let me install that. Perfect, so we have added two packages. Now all we have to do is, since here we are using dependency injection to get the logger implementation, we have to tell application that hey, when a logger instance is needed, do not give the default logging instance that you were giving so far. We want a custom implementation where it will use Sirilog. That registration we will do in program.cs. So right here, we need the log using Sirilog. On there, we have the .logger. We will register or rather configure the Sirilog logger right here. So this will be new logger configuration. And what are all the configuration we want on here? One of them is the minimum level. Here we basically define what is the minimum level that we want. We will only log errors above that level. You can set that to be warning, error. We should also have information and warning. So you can select whatever you want. If you want the debug, we can select that as well. So anything above the level of debug will be logged. Next, where do we want to write that to? So we have write to, and we want to write that to file. Because if you remember, we installed sync.file, the Nuget package with Sirilog. So with write to, we will have file, and we need the location. You can add a folder with the name of log / we can say villalogs.txt. We also have one more option here. Let me break this out to a different line, comma, and you can see there are many options that you can define. Like if you want to limit the file size, or if you want to define the rolling interval. This basically means that when a new file should be created. If you use infinite here, it will use the same file forever, year, every year it will change the file, month or every day. We can do every minute as well. It depends on how many logs you have and how big the file will grow with time, but we can keep that every day for now. And once you do that, we have to call the create logger on top of that. Now that is configuring the logger configuration using Sirilog. But we have not told the application that we need to use this Sirilog logging configuration rather than the built-in console logging. To do that on builder, we have host and we have the method there, use Sirilog. That will notify the application that it does not have to use the built-in one, it will rather use the Sirilog logging. That's all that we had to do. So that is one of the biggest advantage that comes with dependency injection. Wherever you are using the logger, even if you change the basic implementation, you do not have to change anything in the controller. The implementation can be modified like this. So with that, let's run the project. And let me examine the folders here. You will notice a new folder with the name of log was created, and it added the log.txt as well. If you try to open that, it does not work because it is already opened, but let's try the get here. That worked here. Let me close the application. And then if we open the log here, you will see all the logs right here. There are quite a few logs here because we have the debugging level, but if you only added the information level, then the logs will be much lower. Right here, we have the information log that we added, getting all villas. So that way you can customize logging, and we have seen how to use Sirilog to log that to files. Now right now we will be using the default implementation, so we will remove this from here, but if you have to add that, you know what exactly you have to add. But if you do need to add that, now you know how to add and customize Sirilog in the application. If we go to our solution also, it makes sense to remove the Nuget packages if you do not use them. So we go to the install tab, and let me uninstall the Sirilog packages to keep our solution clean and tidy. Perfect, we will remove the using statement. Let me build this, and great, that is working as expected. With that in place, let's continue from the next video. In this video, I want to show you a little bit more with dependency injection because I feel that is a critical aspect when you are working with .NET Core, whether it's an API or a web application. We have the built-in logger here, but let's say for some reason that logger was not there and we wanted a custom implementation of logger with dependency injection. For now, just forget the logger that we have in the .NET Core application. How can we implement something like that and register that to the container? That way, we can use dependency injection to retrieve a logger. We will remove the default logger here and replace that with the new logger that we implement. So let me just remove all of this for now. Here we have errors, but do not worry, we will fix those. First, we need to implement a custom logger in the application. we will remove the log here. And let's create a new folder. I will call that as logging for now. Inside there, we need to create an interface first. So we will call that iLogging. And then let's add a class that implements that interface, which will be logging. Inside the iLogging here, we will add one method, public void log, where we have to write the message and type, which can be like error, information, and so on. So we will implement that right here. So this will implement the iLogging interface. We will implement that interface here, and we need to implement the method. We will keep things super simple. If the type is error, we will write error and then the message, else we will directly log the message in the console window. Pretty straightforward here. So with that, we have an implementation of logging, and we have the iLogging, that is the interface. If we go back to the Villa API controller, here we had _logger, but this time we will create an iLogging, and that will be _logger. Now similarly, we want dependency injection here, and we want an implementation of this iLogging interface. So right here, we will have the iLogging. Let me call this logger, and we'll say _logger is equal to logger. Perfect, that is great. But here we do not have the log information, we just have one method which is log. So let's replace that here. That looks good. We need to pass another parameter here, which is the type. Let's keep it empty for the first one. And for the next one, let's add error here. That way we see the difference. Where was that? We have the type error. We will get this error keyword in the log. So that looks good. The error goes away and perfect. That is exactly what we did with the built-in logger. But that logger, as I said before, it was already registered in the container. That is why you were able to retrieve that with dependency injection. But right now, if we ask for an implementation of iLogging, the application does not know that it has to give this implementation. Let me run the application and show that as well. We do the get here, try this out, and execute this. If we scroll down inside the response body, you see the error message, unable to resolve service for type iLogging, because it does not know that what is the implementation that it should take. We have to explicitly define that because this is not a built-in container service. So that we will do inside program.cs. In order to register that, we will do that on builder.services, not add controller. We have something called as add scoped. Now there are multiple lifetime when you register a service. The maximum or the longest lifetime is add singleton. This is created when the application starts, and that object will be used every time an application requests an implementation. The one below that is add scoped, and scoped is basically for every request, it will create a new object and provide that where it is requested. The lowest one is add transient. This means that every time that object is accessed, let's say even in one request, if that object is accessed like 10 times, it will create 10 different objects of that and assign that where it's needed. For logging, we will be using singleton because we want only one logger that will be used throughout the application. Then right here, we first need to write what is the interface, that is iLogging. We will have to add the using statement, and the implementation of that is inside logging. And that looks good. That's all that we had to do to register service in the container. Let's go back and let me try that. Perfect, we get the logs for getting all Villa. Let me minimize this, and we will try to get that with the ID of 0. And great, we get the error message. So that is also working as expected. And now we have seen how to add custom services to our container. The benefit of dependency injection is in future, let's say you want to change this logging implementation to, let's say, a logging v2. So right here, if you have logging v2 here, and right here we want a little bit different implementation, like we have the same log method with message and string, but if this is error, we are changing the background color as well with error and warning. Let me try that here. Whoops, we forgot to change the implementation in program.cs. We don't want logging, we want the logging v2. Let me open the console window here and now try this one. That is the basic one, but if we try the one with error here, things will be different. Great, we see the red color. So that is how easy it is if we have to change implementation when we are using dependency injection. So with that, I will commit the changes. This is section 4. I will call that custom logger and commit that. Perfect. Now I do not want custom logging in the application. I am happy with the default one. So we will remove all the unnecessary code, but I added that in the GitHub commit. That way, if you want to compare the changes, you can always do that from my Git repo. But for now, let me remove everything that we added. And the API controller. We don't need any logger in dependency injection right now. We will keep that empty. Perfect. Let me build the project. We don't have any errors. Let me run this. And great. We should keep our code as clean as possible. So with that, let's continue from the next video. We have seen logger and how to add that to dependency injection. Now we want to work on the real world scenario of adding database in our application. Because so far we are using the Villa store, which is okay for testing that, but once we restart the application, the data goes away. So in a real world scenario, we typically work with a database, and in this case, we will work using Entity Framework Core. Entity Framework Core is an ORM that makes all the management of data, all the CRUD operation, super simple, using one-line code rather than writing complex queries. In order to add support of Entity Framework Core in our package or in our website, we need to make some changes. But before that, we need to think about what will be the table that we want in our project. When we expand the models, we have the Villa model right here. That is what we want to create in our table. We want it to have multiple columns like ID, name of the Villa, created date. We will also want like an updated date, and then we want more properties for our Villa. So right here, let me create more properties. We have a details for Villa, we have the rate that we want to charge, square feet, occupancy, image URL, and amenity. Now here we are not working with the image directly, but we just have the image URL. Because many times images you might store in Azure Storage Explorer or some other place. They might also be in your application, that's okay. But we will consider image URL right now, and then we will see how to handle different situations. But these are basically all the columns that we want in our table. That looks great. Now that we have added all of these columns in our table, we also need to update the DTO. Because right now, DTO is what we are working with our API. We already added the occupancy and square feet. So let me add these two. We do not want the created date and updated date in DTO. We do not want to expose that. We will add the details and rate here. And perfect. That looks good. We can make rate as a required field as well. Let's go back to our Villa DTO And we have these properties that we want to create a table using Entity Framework Core. Now when we create a table, there needs to be a primary key. So this ID column, by default, if the name is ID, then that will be created as a primary key. But if you want to be explicit, there is a data annotation for key, and you can use that as well. But when we do that, we have to install few Nuget packages. So before we continue with that, let's install all the Nuget packages that are needed for Entity Framework Core in the next video. Now before we proceed further, we need to install Nuget packages for Entity Framework Core. Let's install all of them in the next video. We need to install multiple Nuget packages for Entity Framework Core. We will right-click on the project here, Manage Nuget Packages. We will search for the package Microsoft.Entity Framework Core. We will be using Sql Server as database, so if you examine, we have Microsoft.Entity Framework Core.Sql Server. We also have to install the Microsoft.Entity Framework Core package, but if we install the Sql Server, that package will be installed automatically because of the dependency. You can see it is dependent on relational, and if you examine relational, that has Entity Framework Core. If we only install Sql Server, it will get the relational and Entity Framework Core as well. Let's install that by selecting the correct version here. That looks good. And the next package that we need is Entity Framework Core.Tools. Let's install that. So perfect. Those two were the only packages that were needed right now. With that, let's continue from the next video. We will be using Sql Server for database, so make sure that you have Sql Server Management Studio installed, and on top of that, when you try to connect here, you can connect to any server name as long as it works. LocalDB MS SQL LocalDB, that works here, but if you also have just dot, that is also good as long as you are able to connect. So whatever server name you are able to connect here, that is the server name we will use for connection string in the upcoming videos when we configure that in our application. With that basic overview, let's continue from the next video. We have added the Nuget packages that are needed. If we examine the Villa entity that we have, this will actually be all the columns that will be created in the database. That is actually what we want. The ID column here, we want that to be a primary key, and we want that to be an identity column. What I mean by that is when we create a record, we will not pass the ID. It will automatically increment by 1 every time a new record is created. So in order to tell Entity Framework all of that, we first need to say that this will be the primary key. So we have the key data annotation. On top of that, we want this to be an identity column. So for that, we have database generated. We will press Ctrl dot here, add the using statement for data annotation, and here we have database generated option dot. We have few options here like identity, computed, and none. We will be using identity for now. That will make sure that it is automatically managing the ID for us and we don't have to handle that. Then in the database, if you want something to be required, you can add that as well. We already add that at the DTO level, so this can be good for our entity model. Now we have defined what we want in our database, but how do we actually create this table? When you work with Entity Framework Core, you do not do anything in the database directly. Everything will be done from the code itself. We are using code-first approach. And when we work with Entity Framework Core, we need a DB context that will manage all the entities in our application. So inside the data folder, let's add a new class file. I will call that application DB context, and let's add that. This class will inherit the DB context. That way it will get all the built-in functionalities, and that is inside Microsoft.Entity Framework core. And then whatever entity we are managing, like in this case, we have the Villa entity, we need to create individual DB set inside the DB context. So we'll say prop, press tab twice, we need to create a DB set on. Right here, you see it expects an entity, that is the Villa entity. We will add the using statement, and we can call that as villas. Now the name that you give to this entity will be the table name that gets created in SQL Server. So if you call this Villa_API, that will be the name that your table will have in the database. We will call that as villas, and that looks good. When we will be querying the DB set, we will be using link statements, and those link statements are automatically translated into SQL queries by Entity Framework Core. That way we don't have to write queries when we work with Entity Framework Core. With that configuration in place, we need to add connection string to connect to our SQL Server. So let me add that in application settings.json. Right here you see we have a logging block, we have an allowed host block. Similarly, we will be adding a different block. Now there is a predefined block with the name of connection strings. That way there is a helper method that will help us retrieve the connection string by default. So make sure to use exactly that one. If you use different one, then the retrieval is still possible, but then you will have to use custom name. So we will use connection strings here, and we have to give our connection some name. So let me call that as default connection, or rather to be more explicit, let me call that default SQL connection. That way we know that this is the connection string for our SQL Server. Then right here we have to write the connection string. Server name I am using dot. If you remember, I was able to connect to that on my SQL Server. If this does not work, you can use MS SQL local DB as well. We will give our database the name of Magic Villa. Let me actually say magic_Villa API. Trusted connection will be true, and multiple active result sets will be true as well. So we have defined the connection string now. In the next video, what we want to do is we need to link this application DB context to use the connection string, and we have to register this to Dependency Injection. Let's do that in the next video. Now we need to connect the application DB context with connection string. That way it knows where is the SQL database, and we need to add that to Dependency Injection. When we have to add things to container, we go to program.cs. So right here we will say builder.services, and we have to add the database. So we have something called as add DB context that is provided. On here we have to define the class that inherits the DB context, which is application DB context in our case, and there we have to provide options with the connection string. So we'll say option goes to, we have option dot reinstall the package for SQL Server. So we can say .use SQL Server, and when we press Ctrl dot, we have to add the using statement. Inside the use SQL Server, we have to provide the connection string. Where is that connection string? That is inside appsettings.json. We can access that directly using builder.configuration. We have a helper method here, which is getConnectionString. And you can see that is a shorthand for getSection, and section name is connection strings there. That is exactly what we have in our section name when we were adding connection strings. And inside that section, our name is default SQL connection. Let me copy that. So rather than using the get section here, and then passing the section name, which is connection strings, and then passing the name outside, we directly have the helper method, get connection string here, and we directly pass the name right here. That will retrieve the connection string and it will pass to the use SQL Server. Let me add the semicolons here, and perfect. That looks good. Now this connection string, we know it will not be empty, but if you want, you can throw an exception if that is empty here to make this error go away. But I know that is present in app settings, so this is good. So what we are doing is where we have the application DB context, we are passing the connection string. That is great. But now if we go back to application DB context, we have that right here, but we have to pass that connection string to the DB context as well, because we will be using the basic features of the DB context most of the time. And if you notice in program.cs, we are getting that as application DB context in parameters here. So right here, we can add a constructor where we expect the DB context options. We will call that as options, and we just pass that on to the base class, which is DB context. These are the basic steps that are needed to configure Entity Framework Core in any .NET application, whether that is an API or a web project, MVC, Razor Pages, or Blazor. The steps that we just did always stays the same. But with that, Entity Framework Core is configured in our database and we have made good progress. We still need to create the database and create the table for Villa. Let's do that in the next video. I have said before that when we work with Entity Framework Core code first method, we never touch the database. We always apply all of the DB changes from the code itself. And for that, we have to do something called as migration. So we go to Tools, Nuget Package Manager, and we have the Package Manager console. We have added the DB set in application DB context. So now we need to create a set of script which will tell database that you need to create this table. To create that script, we have the command here, which is add migration, and we have to give our migration a meaningful name. I will call that add Villa table. Here there are few things that you should see. Right now we only have one project, that is why the default project is Villa API. Our DB context is inside the Villa API project, so the default project that we have as Villa API, that is good enough for now. But if you have multiple projects, you have to make sure that default project is the one where we have the DB context. But with this, let's press the enter button. If there are any build errors, it will display those errors, but if everything is good, it creates a migration and it adds a new folder with the name of migrations here. If you examine the migration, you will notice that it has a special create command here, which is for create table, and it has all the columns. Now this is not your typical SQL statement, but it is a link statement, and based on this, Entity Framework automatically creates the table and all the query. We have up and down here. Up basically means what it needs to do, and if this fails for some reason, it will roll back the changes. That is pretty smart. Now how do you apply this migration? To apply that, we will go back to the Package Manager console and we will run the command update database. It will first check if the database is present. If it is not present, then it will create that and then create the table. We have an error here. Let me see what that is. It says a connection was successfully established with the server, but then an error occurred during the login process. Google is your friend, so let's try that. We have the issue here. Let's scroll down. And we just need to add the trust server certificate to be true. Helpful as always. And we will add that in the connection string. We will run the command update database one more time. And great, it worked. So if you get any weird error, you know Google is always there, and that should always be your first resort, and that should always be the first thing that you do that will help you long term. So perfect, migrations are done here. We need to switch back to SQL Server. We have the dot here. If we expand the tables, we have magic_villa, and that is created. Let's examine the tables there. Great, we have two tables. Let's first examine the villas table. And great, that has all the columns that we wanted. But now let me also examine what is this EF migrations history table. This is the table that keeps track of how to synchronize the migrations that we have in our code versus database. You can see right here, this is the migration that we added. And in the table here, it notifies that this migration has already been applied. So next time when you add a new migration and run the command update database, it will not add the migration that has already been applied. It will only apply the new changes. That way, Entity Framework code keeps tracks of which migrations have been applied and what it needs to apply next. Everything is pretty smart, and you do not have to touch the database to make any DB changes. So with that, we have made great progress. We have added connection string to our project, configured Entity Framework core, and we also created our very first table in SQL Server. Also, I would like to point out the name of the table should be villas, and that is exactly what we have. So with that configured, let's continue in the next video. Now that we have database configured, we do not need the villa stored anymore. We can delete that. But if we go back to our database, right now our table is empty. What if we automatically want to seed this table with a couple of records with migration? How can we do that? We will have to do that in the application DB context. Where we have the DB set, we have one method that we can override for migration. So we can say protected override. The method name is onModelCreating. And there we have model builder in the parameter. That is exactly what is needed to override the onModelCreating. There we can use the model builder and we can use entity.villa. We have a method there which has data, and here we can seed with new villa record. So basically what we can do is inside here we can say new villa, and we can create all the properties in there. Like for the first one, we will say ID is 1, name, let's call that Royal Villa. Details here, we will add some dummy text. It's lorem ipsum, so you can get that. Just some dummy text here to get started. Next, we need the image URL. Let me keep that empty for now. We have occupancy, keep that as 5. Rate, let's keep it 200. And square feet, let's make it 550. Amenity, let me make it empty. For the image URL, I will provide some free image URLs that you can use. So I have added that URL right here. But now you might be wondering where I will get this data from. I will provide all of that in snippets on .NET Mastery, so you can go there and download the project resources. Once you download project resources, you will go into snippets there, and we have section 4. In there we have the seed villa table. You can just copy this directly and you can seed them right here. So we will paste it right here. We are creating 5 villas here. That looks good. Everything is done inside this model builder.hasData. Perfect. Now we just have to add a migration. So I have the package manager console here. I'll say add migration, seed villa table. Let's see what happens. And great, you can see it added an insert data statement and it is inserting the records right here. I notice the date time is not valid, so what I can do is I will add one more thing here where we have the created date. This should be datetime.now. Let me add that in all the places. Perfect. Now you have one question. We already added a migration seed villa table where the datetime was not valid, and we updated something in the DB context where we added the created date. Now should I delete the old migration and add a new migration, or what should I do? You will never delete any migration unless you are confident on what you are doing, because that will mess up everything with Entity Framework Core. Entity Framework Core is super smart. So all you have to do is you will add a new migration, and we will have to call that something else. We will say seed villa table with created date. Let's see what it does. You can see the only thing that it is doing is updating the date for all the records. So it already knows that there is a migration which is taking care of creating those records. I only have to update them because that is the only thing that is changed in the on model creating. Pretty smart. With that, let me run the command update database and we will seed our table. Great. Let's go back and we will do select star. Perfect. We have 5 records here and everything is working as expected. Now our table has some records. Let's continue from the next video. Now comes the big thing. We have the Villa API controller where we were using the Villa store and we need to replace that with our DB context. Let me delete the Villa store. We should not be using that anymore. So what we should be using is the application DB context, and we already added that to our container when we added the DB context right here. Because we have registered the service in our container, we can extract that using dependency injection. First thing, we have to create a private read-only application DB context, and then in constructor, we will get that with dependency injection, assign that to the local variable here. We have to get all villas where we need to retrieve all the villas in the database. Doing that is super simple in Entity Framework Core. We will use our _db. If we press dot, it will display all the DB set that we have in application DB context. We have the villas in there if you notice right here, and if you do not write anything else here, it will automatically retrieve all the villas using this statement. If you want to convert that to a list, you can do .toList here, but this is basically the 2 words that you have to write to retrieve all the villas. No SQL query is needed here, and that is fantastic. So with that, our get villas looks good. Let's scroll down where we have to get individual villa. Now we know if we have to get all the villas, we have db.villas, but on there, Entity Framework Core also provides first.default. So if you write first.default from the villas table, it will write the SQL to retrieve the villa where ID is equal to this ID. We do not have to write any SQL. Entity Framework Core takes care of all of that. Let's move ahead here. We have the create villa where we need to first check if that villa exists or not. So we can do _db.villa.first.default. It will do all the checks automatically. Pretty straightforward. Next, we are assigning the ID here. That is no longer needed with Entity Framework Core because ID is an identity column. How do we add a record to our database? So _db.villas, and then we have a helper method which is add and add async. Async is used for asynchronous calls. We will go with the basic add for now, and we need to pass the entity in the parameter. So that entity is villa DTO. We can add that. But when we do that, we run into an error message. Let me remove the line after that. The error that we have here is we are passing an object here which is of type villa DTO. But the entity that villas is on, it expects a villa. So it cannot implicitly convert villa DTO to villa. So we have to do a manual conversion like this, where we will create a new villa here and we will manually map all the properties from villa DTO to our villa model. And then if we add villa model here, it is able to add that successfully. Now right now when we have the add statement, this does not mean that when it gets executed, it will automatically add the villa. Right now it is keeping a track of everything that it has to do. But in order to make some changes, we have to call _db.savechanges. That will gather all the changes that it has to make and it will push them when we call the command save changes. That way if we have to add 3 entities, we can keep on adding them and then we hit the command save changes. That way there is only one database call as compared to 3 separate database calls. That looks good. We have the delete villa. We need the first.default, so _db.villa.first.default. And then to remove, we have _db.villas.remove. And we need to pass the villa object. Here we did not have to do any conversion because when we retrieve it from the database, it will be of the type villa as you can see here. So remove is functional with that. But again, you have to save the changes. Next, we have the update villa. There, if we were not using Entity Framework Core, we had to retrieve the villa from the database and then update each one of them. Entity Framework Core is smart. Based on the ID, it will figure out what record you have to update. So you do not need any of these things. We just need to convert villa DTO to villa object. So we will do that right here. And then on this model, we'll say _db.villas. We have the update method that expects a villa object. So we will write our model here, and that will automatically update all the records. Pretty smart. We will just say _db.savechanges. Alright, we are making great progress, but now we have the patch request, and that will be a little bit tricky. First, let me say _db.villas.first.default to retrieve the actual villa. Because in the patch document, we don't get the complete object, we only get the field that had to be updated. Now here the type is villa, but when we are applying here, you can see the type is villa DTO. So we will have to convert this villa into villa DTO, other way around on what we have done so far. So right here, we will have a villa DTO and we will convert our villa into a villa DTO object. Once we do that, we will apply that. So right here, we will have villa DTO and we'll have model state. So basically any changes that we have in patch DTO, which is of type villa DTO, that will be applied to this local variable villa DTO. Once we have that, then we can update the record. But in order to call the update in Entity Framework Core, that has to be of type villa. So we will have to convert this villa DTO back to villa before we can update that. And once that is done, we will say _db.villas.update. We want to update our model here. And we will say _db.savechanges. There were few conversions that we had to do here, but again we are using update here that will basically update the complete record even if just one record was updated. Ideally, if you are using patch, you will go into some stored proc and create a stored proc to update one record if that table had many columns and go along that route. But that is way beyond the scope of this project. That is why I am keeping things simple, but I wanted to give you a brief idea of patch as well. This will make sure the patch is functional. So with that, I believe everything is converted to use application DB context here. Let me build the project and make sure this works. Perfect. Let me continue from the next video. Let me run the project here and see this in action. Perfect. Let's try the get here and let me try that. We should retrieve 5 records that are there in the database, and great! That is working as expected. If you examine the logs here, you will notice that it executed a select statement from Villa. Perfect. Let's try the get now based on the ID, and let's try that with the ID of 3 here. Perfect. We retrieved a record right here. So get is working. Get all is working. Let's try the post, but in there let me copy one record so it's easier to create that. Post here, let's try that, and let me paste what we copied here. We will remove the created and updated date, and let me change few things here. I added 6 in front of everything here. The ID will be 6. Execute that. We scroll down here, the response is 500. We ran into some error on the server. Let's add a breakpoint and debug that. So we have create Villa here, add a breakpoint. And let's press F10 here, first our default. Whoops, we are passing an ID, and of course that will give error message. We should have been more descriptive with that. But we do not need this ID here. Let's go back and remove the debugging point and execute this. Perfect, we get a 201. It was created. Let's check our database here. And great, we have the 6th record here. So post is working as expected. Let's try put here to update that. And let me go to post and copy. That way updating is easier. Let's scroll down. The ID is 6. Let me double check that. Yep. And I will paste it right here. ID will be 6 here. And let me just make this 7. And see if that works. Execute. Scroll down, 204, no content. Let's go back here. And perfect, we have the 7 that we added. That looks good. So our put is also working. Let's try the patch request for 6 here. Path, let me update the name here. Operation, it will be replace. We don't need the from. Value. Finale 77, let's try that. Now when we try this, we will run into an error message. The instance of entity type Villa cannot be tracked because another instance with the same key value of ID is being already tracked. This can be a common error with Entity Framework Core. We will have to step back here to analyze on what Entity Framework actually does. But so far we have seen everything else other than patch or partial update is working as expected. So let me explain the issue that we face here in the next video. Now how does Entity Framework Core does the update? You can see we have the Villa here, so whenever we use first or default, it actually keeps a track of that entity. So right now, when this line is executed, it is tracking the Villa with the ID of 6 that we added. Then we scroll down here, we go to patch, and finally when we are updating here, we are passing a model with the same ID of 6. Now Entity Framework is confused here because it is already tracking that object. Because of that, if you want to update something directly here, you can just say villa.name is equal to new name that we want here. And if you say _db.save changes, it automatically updates the name. This is a different way of updating anything using Entity Framework Core. Let me show that in action as well. So right here, we will try patch again, 6, and let me just execute. We don't care about what's the parameter. You can see it retrieves the villa based on the ID 6. That looks good. The name right now is Royal Villa with some numbers there. We change that, and then when we save the changes, let's examine what is the villa. You see it gets the new name. Let me stop. I don't want to proceed further here. If we go back to SQL Server, you will notice the name is updated. So Entity Framework Core is already tracking the villa if you update any property, and without the update command, if you hit save changes, it automatically updates that. We do not want this feature right now. We do not want Entity Framework Core to track this villa that we are retrieving because we are not making any changes to this villa object. When we are updating right here, we are passing the model, and we want Entity Framework Core to track this model and update that. And the error that we saw is because it was trying to track both the models with the same ID. That is not possible. It can only track one ID at a time. So for that, when we retrieve this first or default, we do not want it to track that. Doing that is super simple. We will have to add as no tracking here to tell Entity Framework Core that when you retrieve this record, I do not want you to track that. We will have to add the using statement for Entity Framework Core, and let's run the project this time. Let's try the patch again. And we will change the name to Hello World. Let's see if that works. We execute that, and we get a response 204, no content. Let's go to SQL Server here, and perfect. That works. So in this video, we learned something critical with Entity Framework Core, which is as no tracking. Every time you retrieve one record, Entity Framework Core is always tracking that. So if you do not want it to track that, use the as no tracking. That way it will not track that record. But with that, all the CRUD operations on our Villa API are functional with Entity Framework Core.